Welcome, everyone. Thank you so much for joining us for today's webinar. My name is Liz Marks, and I'm the Director of Product Marketing here at AEM. Today, we're really excited to share how AEM's weather stations are built to support every mission, from local operations to national networks. We're going to start by looking at the need for weather stations today. Why do they matter, and some of the challenges that organizations are facing when choosing one. Then we're going to introduce AEM's enterprise portfolio, and we're going to share a few examples of how our stations are applied to different customers and different needs. Next, we'll cover how AEM Elements 360 takes that raw station data and makes it usable, turning those observations from the stations into those decisions that you rely on. And we'll also share some practical guidance on how to select the right weather station for your situation, since there are so many options in the market. And then finally, we'll wrap up with time for your questions. Now let's meet our presenters for today. Bjorn Mostseen is an experienced strategist in the weather and environmental technology sector. As sector leader for severe weather at AEM, he helps industries such as aviation, energy, construction, and maritime harness precise weather data to enhance safety, efficiency, and resilience. With nearly 15 years of expertise in engineering, business strategy, and global partnerships, Bjorn drives innovation that shapes the future of weather intelligence. Russ Heilig has been shaping the field of environmental sensing and data technology for more than 25 years. At AEM's Davis Instruments brand, he played a key role in creating the Vantage Pro and View weather stations and launching the WeatherLink network. Today, he leads AEM's hardware product portfolio, helping organizations collect and share reliable weather data to improve safety, efficiency, and decision-making. And with that, I will hand it over to Russ to talk about the need for weather stations today. Russ?
Good day, everyone. As Liz mentioned, I'm Russ Heilig, and I oversee the hardware portfolio here at AEM. I started my weather journey actually over 30 years ago, and it was a summer intern at Davis Instruments. So some of you know Davis from the old days was the home weather station pioneer. And as a summer intern, I actually struggled with figuring out why someone would actually want a home weather station. And so I would talk to people and understand what the reasons were. And I quickly found out that a typical person would say, I'm interested in my weather, not the airport weather, because as you know, no one lives at the airport, right? And so I started to understand very quickly that local mattered, that people wanted to know what their wind speed was, not the airport's wind speed or some other location. The number in many cases is tied to very specifically where you are. It might be a sink in the topography. You're trying to get a different temperature sensor than everything that's around you, and you need the right number for frost prediction. Or maybe it's a sports field that you're making sure the kids are safe if they're playing football on a hot afternoon. It's where that matters a lot. What I also noticed is that they just wanted to know. There was a real need to have information and what they would consider ground truth, which is a great term. It is the truth. It is the place that you're looking and the data that you're seeing. 30 years later, now I fully understand what really comes down to is that weather impacts every business and every person. They just want to know. It may be for a hobby. In very many, as soon as we started moving into industry specifics, it was really driving daily decision making, long-term planning, and actually most importantly, safety of people and property. So as I learned, I understood how clear the need was for the data. But how you get your hands on it is a different story. So obviously there are great tools out there today already. There are broad networks, NOAA and others. Airports have great weather stations. There's a multitude of phone apps you can use to decide whether you need your jacket or not. But what works for, say, a vineyard to do water level monitoring or their crop yield is very different from someone out there at the urban wildlife boundary trying to capture high wind speed readings to decide whether they're going to shut off power for worry of fire or not. The basic information is the same. You need a basic set of weather data, but what's important to you and what you're making your decision on and what your setting is can vary quite a bit. It's easy for a vineyard owner to grab a ladder and clean the rain collector. Not so much if you're 30 miles away or more and you're on the edge of cellular capability. The situations are just different. So the challenge, I think, is clear for us as providers and for users of weather stations. You want accurate data, but you also want site-specific and reliable data if it's going to support the decisions that you're trying to make. So I think the real question here is you need to know first off, and essentially you need to know there at that spot. So the there is here. Right? This is a nice representation of really all of the kinds of places you might want weather information. But as you can imagine, what you want to know and how often you want to know can vary quite a bit. We know that the weather affects every one of these scenarios, whether it's an airport or a farm or a stadium or just the urban setting. But the reasons you might want the data will vary. Right? An emergency manager might want a forecast on certain things just to protect public safety. Farmers may want to know both how much rainfall has fallen for their crops, but also whether they can drive a tractor on the field. Utilities need very site-specific information for safety purposes and knowing how to operate their grid safely. Construction sites might need to know if it's too cold or dangerous to have people out there working on their site. And then obviously there are ports, airports, national agencies all have their own specific weather requirements, maybe some very high precise requirements in terms of the instrumentation. So all of them share risks, downtime, safety hazards, compliance issues, asset damage. These are all things that are possibly cross-cutting on a lot of these industries, but the needs for data, the accuracy, the budgets, a lot of things will matter in terms of understanding what you're going to actually implement in any of these situations. A one size fits all just doesn't exist. I think you need to have a one size fits some and really understand what the specific need is for your particular situation to know which pieces and parts are putting together to create a real solution for you. So you can see one thing that's nice about AEM is we can outfit any one of these with different variations of solutions. And we also have a software platform that can coordinate them. So when I look at a picture like this, I see maybe 4 or 5 different ways to collect the data, but one way to see it. And I think it's really important to know that if you are either you're cooperating with another agency or maybe you're just contributing to a larger regional network, that the data can all find itself into the same place so that the users of this data can see a very broad picture of what's happening. So now just to introduce to you what we call our enterprise portfolio. It's really a range of station types. We have a lot of history in different instrumentation from Lambrecht in Germany, generations of high quality weather instrumentations. I'm coming from Davis, and it's at least a couple of generations of very reliable and budget conscious weather stations. And we got in the middle, we have really the opportunity to take some of the best of both worlds and build solutions that draw on some of the skills from both sides historically, and also pay attention to the particular needs of an industry, whether it's their data collection requirements or their transmission requirements that really suit a certain area. So the way we've pushed these 3 into sections is to say, we've got a level for you, both on from a value point of view, a budget point of view, all the way up to a high accuracy, UMO specific point of view as you walk through. And what we try to do is really to make some sense of all of the myriad options you can have. So now we're going to move on to the 3 sections of Vantage, because I know it for a very long time. But basically, it's this is basically our single site infill, best suited where you want reliable data, simple to install, maintain data, but maybe where you're not as concerned about a research grade specification. So obviously there's always a trade-off in a cost for performance or a cost for materials. Vantage, you can consider the cases where I want the data, I don't need research grade instrumentation, and I'd prefer either because I'm on I have a tighter budget, or I want just more weather stations to cover. So when you're looking at a case of an overall ecosystem of weather stations, this can be your first layer of just points of presence in a lot of different places. So every school, every fire station, every place you can think of, it's a reasonable option, not very expensive, and still can contribute its data all the way back to a central point. So you see the suitability, it tends to be schools and parks where maybe the budgets are not unlimited, but they still want to have really good data so that they can help their people and actually make some good decisions at the site level. So just to give a couple of quick examples of the Vantage in its place. This particular one is on a fire station, and clearly a fire is interested not only in the active fires as they are, but in the cases where there can be a fire danger. And so it's an ideal place. You can have a weather station locally to the fire station, and they can monitor it. They can also have a collection of fire stations all contributing to a central point so that you can judge if there's any information or worry about an area in general. And of course, you can also push this data to your local community. That's one of the things that's very nice about having a lot of weather stations. It's similar to the old days of a home weather station. Now you're giving the community another weather station point, so they can feel like they know the weather in their neighborhood, not necessarily from the airport or some other regional thing, or synthesized from some app. So we've been operating in local schools, municipalities for as long as I've been at the company. The budget is great for them, and the maintenance and the reliability are both. The reliability is good, and the maintenance is relatively easy because they're built to really be self-service. So farms, again, one of the first places I think Davis moved from just a home weather station was into agriculture, because it was clear that when a farmer's trying to make their decisions, all of the features, whether it was wind speed, rainfall, temperature, humidity, they all played a part in the kind of decisions they were making, not only for just whether it's safe to use in the farm, but also just to track their crops, to see how they're progressing. Over time, we've added soil moisture so they could see basically the whole water cycle of their crop. And again, built in a way that they didn't need to the nth degree of precision. They just needed a really good number, and they wanted ways to make it easy enough that they could put it up in an afternoon or a couple of hours. So when you see the pictures here, you're really looking at a weather station out of a box, and the loggers, those boxes are really the data transmission, also out of a smaller box with simple connectors, just to make the whole process as easy as possible. And so we've been operating in farms forever. It's really a strong suit for us because it really combines the need for reliable data and simplicity. So finally, in the case of Vantage, another good example, I just want to stress that these are some of many examples we can give for suitability. But construction is really good because, again, you need something that can be deployed relatively quickly, simply. It's in this particular case, if you strain your eyes to the corner, there's a simple weather station just hanging off the end of the Freedom Tower while they were doing the construction in New York. It's getting the data that they need. Again, that they're not doing any studies on the data. They just need to know reliable wind speed, temperature, and data getting back reliably to a central point so they can understand if the conditions are safe for people to operate, and if there are any extreme conditions that will keep them from doing their jobs, whether it's concrete setting or just too rainy to get any materials onto the site. So Vantage in that case is really good because it's got the simplicity and but still very rugged system for use in construction.
Good day, everyone. My name is Björn, and I will move forward now with you over our Ascent weather station through the Apex line and talk a little bit about Element 360. We will start now with our Ascent weather station line. Think of Ascent as a backbone of challenging environments. While Vantage handles everyday monitoring, Ascent steps up when conditions get tough. Think about this and keep this question in mind. How many of you work in industries where weather isn't just inconvenient, but potentially dangerous to operations? So Ascent delivers their key advantages here. Budget precision for harsh environments, modular design that grows with your needs, and defensible data for safety and compliance. Before we dive into specific applications, let me set the stage. Every industry well discussed today shares a common challenge. They cannot afford to make weather-related decisions based on incomplete or imprecise data. The cost of being wrong isn't just financial, it's measured in human safety and environmental impact and operational continuity. Regional weather stations are designed for broad area forecasting, not precision operations. They like using a city map to navigate your neighborhood, helpful for general direction, but not detailed enough for precise navigation. Our first major application, area demonstrates exactly why precision matters, and it might surprise you with its complexity. Maritime ports, these are some of the most challenging weather environments on Earth. Port operations need critical things, yeah? They need crew, worker, human safety, infrastructure protection, and smooth operations at the end. Think about this scenario. A port operation manager needs to decide whether it's safe to operate a crane. The National Weather Service says winds are 50 miles per hour. But at the specific site, which is between two buildings or many containers, the actual wind speed could be 25 miles per hour or higher due to the wind tunneling effects. This is the difference when using data only from yesterday, today, or tomorrow to run your operation instead of a local weather station. Why does Essen is the right fit? You see no moving parts, seawater resistant for this environmental and really compact design. We also offer different ways to provide heat stress information for human safety if needed. Let me paint a more complete picture of why maritime environments are so challenging. Salt air doesn't just corrode metal, it's create electrical conductivity. Issues that can cause false readings in traditional sensors, temperature differential between water and land create complex wind patterns that change hourly. So you see you have really different challenging at a port and also everything what's going around there. As you can see in this image, ports present unique challenges. Notice how densely packed everything is. There's barely room for essential equipment, let alone weather monitoring infrastructure. This is why Essen's compact design is just convenient. It's absolutely essential. And see those massive cranes, they create wind shadows and acceleration zones that our weather station 5 kilometers away could never detect. Okay, we can move. So that is a short snapshot about ports, but ports aren't the only maritime application. Let's look at passenger vessels. Yachts and cruise ships have completely different requirements, depending on the sensor needs, depending on the data. For passenger vessels, operational efficiency and passenger safety are paramount. Essen delivers advanced technology for this market. We deliver true wind calculation. We have fully NMAA compliant stations and sensors. That is the industry standard there. And this provides you at the end a seamless integration into your bridge system. Quickly for this one, a simple example. So true wind calculation might sound complex, but think of it in this way. When you are driving with your hand out the window, the wind you feel isn't the actual wind speed. It's affected by your car's movement. Ships need to know the real wind speed for safe operations at the end and not the actual wind speed that is only measuring on the ship or on the vessel itself. To calculate this is possible at the end with our equipment. We can deliver the complete solution that's fit for you and can operate on a cruise liner or a vessel or whatever. Also, again, think about what 20 knot winds means for cruise ship with 3,000 passengers. At those wind speed, gangways become dangerous, tender operations must stop, and passengers cannot safely disembark. But there's a critical point. A regional weather station cannot show what actually happened on an 800 feet long cruise liner. Such a large ship uses more than 4 sensors to monitor different situations on board. I know this from my own experience, I can tell you. I was once on a cruise ship when waves were reached to 8 to 10 meters in high. If you enjoy the feeling of a giant swing, here we go. Yeah, that is what you need. But on the other side, so you can say it's the restaurants that are usually really crowded. They aren't crowded, that is positive. But for all passengers, it quickly becomes clear how powerful the nature is. Yeah, if you have this of high waves on the ocean. Another type of vessel is the container ships. So most of the vessels we are seeing on the ocean are the container ships. Container ships that represent the pillar of the global commerce. These massive vessels face some of the most challenging weather conditions by carrying billions of dollars worth of cargo across the world's ocean. When these vessels face delays, weather delays, it affects supply chains worldwide. They have critical navigation system and precise wind measurement for docking and navigating channels. That is really mandatory. Take a look, some channels, they have only 49 meters wide, and when you pass this with container ships in the same way, you need accurate information, that you do not bump into another vessel or a container ship or going too close to the side. Regulatory compliance is another point. Meeting the IMO requirements means the International Maritime Organization. So this type of vessels, they have all meets these requirements, and there we can help you with the equipment we deliver. And think about these massive cranes. We have spoken about this during the previous slide if we have taken a look to the ports. When you have massive cranes moving containers worth hundreds of thousands of dollars each, weather conditions must continuous monitored, because it could be different, completely different, depends where you are. I have the last example on this container ports. Take a look to, for example, a port with a size like the port of Los Angeles. This port is longer than 30 miles, and the wind speeds can difference there more than 20 meters per second. That's also the difference between safe crane operations and shutting down entirely. So the conclusion for the maritime area is this. The combination of regulatory requirements, safety imperatives, and commercial pressures demands weather stations that deliver both exceptional accuracy and seamless integration. Our Essen weather station meets these challenges head-on, providing the reliable integrated monitoring that container operations require to maintain safety while keeping global commerce moving. But Essen will cover much more. Let's shift from maritime to energy and take a look what are the challenges we have in this market. Coming from maritime operations, you understand how weather precision directly impacts operational safety and profitability. Solar farms require the same level of met accuracy at the end, but focused on solar radiation, temperature variations, and atmospheric conditions that directly impact photovoltaic performance and energy output. Solar farm operations demand continuous environmental compliance, monitoring, and seamless integration with control systems. Our WMO compliant sensors deliver defensible data for environmental reporting. Regulatory requirements and production forecasting is another point. At the same time, Essen provides a system capable of handling all your sensors hardware and communicating directly with your SCADA system, inverter monitoring, and grid management platforms. With native Modbus TCP and Modbus TCP slave function, what could be really cool at the end, the station and all connected devices act as single sensor for you, and ensuring in this way seamless connectivity and integration in your system. So with this, real-time performance optimization is possible. And additionally, all the stations are zero comply, what is some recommendation if you are doing a monitoring from a solar farm. Additional parallel data connections for redundancy and latest TLS standards ensure a secure and highly reliable data connection. That means at this side, it is something what came up from customer. You can communicate with your SCADA system, but on the other hand, if you would like to push the data back in some cloud platform or whatever, or also to us, or Elements 360, both is possible in the same way or at the same time. Renewable energy leads us to another critical infrastructure application. Power transmission is the other topic, the dynamic line rating. So dynamic line rating represents a game-changing approach to transmission capacity optimization. By using real-time environmental data instead of static conservative ratings, utilities can increase line load capacity by up to 30% compared to traditional static ratings, unlocking significant additional transmission capacity from existing infrastructure. And at the end, the reason is simple. We all feel this, and also we are slower when it's getting warmer. The air, power lines can safely carry as much electricity. So, but in cold, windy conditions, they can handle significantly more power without overheating, and that is a key factor. Cooling at the end is a key factor, and we can help you with real-time environmental data for accurate transmission capacity. The Essen station delivers precise measurement for wind speed, that cooled everything down. You have the actual ambient temperature and solar radiation. So everything what impacted at the end the power line. It provides exactly what you need to calculate actual conductor cooling effects. Also, as we learned on the previous section, Essent offers Modbus support for network integration, enabling easy deployment and seamless connectivity. At the same time, connection to our Elements 360 platform is possible, allowing us to provide forecast data tailored to your specific location. Now let's shift from heat to cold. So moving over to the cold side, the ice load sensor provides utilities with a dedicated tool for winter grid management. By measuring ice accumulation at the end, it delivers real-time insight into actual loading conditions on power lines. This data supports better decision-making, from refining de-icing strategies to assessing the weight currently stressing the network. And on this point, the sensor is so accurate that you can measuring every millimeter of ice on the power lines. Yeah, it starts by 2 grams, and you can definitely then detect everything where you have growing ice. And as final point on this, the sensor is WMO compliant and really precise enough to measuring everything or fulfill your need. And keep in mind at this point, it's end of September, so winter is just around the corner. We will move now from the Essent line to the Apex line. Essent handles challenging commercial environments. Apex serves the most demanding application on Earth. National Met services, aviation safety as listed, and military operations. Apex delivers uncompromising capabilities. And that is our sensor line. It delivers the highest precision and durability in our entire portfolio, standard compliance, WMO and IKO certified, and future-proof investment with global interoperability. National Met and Hydro Agency face unique challenges. They need typically this following things that no other weather station user require. Seamless integration across national and international networks. When the US National Weather Service shares data with the European Center for Medium Range Weather Forecast, that data must be perfectly standardized. High quality observations to power forecasting models. The difference between a Category 5 and a Category 4 hurricane forecast can depend on measurements accurate to fraction of degrees. And long-term defensible data sets for climate research, climate scientists need data they can trust for decades of analysis. Every forecast you check on your phone starts with the data from a station like this. Apex ensures that data is absolutely reliable. And as we said, it delivers WMO and IKO compliant data. This is also required what we are seeing in our military application. Yeah, military application represents the ultimate test of weather station performance. In military operations, weather data isn't just about comfort or efficiency. It's about mission success and personnel safety and in the most challenging conditions on Earth. Military weather requirements go beyond civilian needs. This requires accurate weather data for safe navigation, precise atmospheric pressure data for helicopter landings on moving vessels, right? So there is also then something required if you have the level of waves or middle of the ocean. So you need really high accuracy of data to sync up the pressure with the helicopter at the end, that he can land safe on the vessel at the end. Operational efficiencies through optimized planning, fuel course, mission timing, and so on. And at the end, we are here in the military area, the weapon and defense systems, yeah, which require reliable weather input and environmental compensation to maintain accuracy. Incorrect data degrades performance and really, to be honest, increase then the risk in a mission. Apex meets these demands with intelligent true wind calculation, what's definitely also helpful on other vessels, but here with a true wind calculation, real-time integration with navigation and the weapon system, and military standard durability. Against saltwater and extreme conditions, and multi-sensor redundancy calculation with the option for this type to calculate disturbance sector. So we move over because having the best hardware is only half the equation. let's talk about turning the data into decisions. Elements 360 is the brain of your weather station system, pulling together site data, mapping, sharding, and alerting in one place. Without software, you risk delays, missed signals, and limited ability to act on the data. The most sophisticated weather station in the world is only as valuable as your ability to turn data into decisions. Great hardware with poor software is like having a Mercedes with a broken dashboard. That's where Elements 360 transforms everything. Let me show you what makes Elements 360 the command center for weather critical operations. Elements 360 serves as a command center of your weather monitoring network. How many of you have ever tried to make critical decisions by juggling data from multiple sources, different formats, pivot table or whatever with various timestamps, bring everything together? So it's frustrating at the end, and it's on the other hand dangerous. Elements 360 eliminates this complexity. It delivers strong transformative capabilities. All your weather data in one place. Elements 360 combines your station data with other trusted sources, satellite feeds, radar data, numerical weather models, giving you a complete view of current and forecast conditions. No more switching between multiple systems. Clear dashboards and maps. The interface provides easy-to-use tools for fast situational awareness. When a storm is approaching, you don't have time to interpret complex data. You need immediate, clear information. Smart alerts. This is perhaps most important. Alerts configurable to your specific needs, minimizing false alarms while improving response time. Imagine you're managing a port. Elements 360 can alert you when wind speed will exceed crane operation limits, and also with our end customer within the next 2 hours, giving you time to secure equipment safely. Instead of having staff check multiple weather sources throughout the day, Elements 360 automatically monitors conditions and alerts you only when action is needed. This frees up your team for other critical tasks. The platform transfers raw weather data into actionable intelligence, enabling confident decision-making when condition matters most. Now that you understand our complete solution, hardware plus software, Russ will provide you practical guidance on choosing the right weather station for your specific needs.
It's helpful to see the degree to which we really think hard about a particular application when presenting the solutions for an industry or an application. There's a lot of thought behind that, and it's so a lot of the decisions are based on conversations priorly held with a lot of people to the point where we can deliver a very specific, tailored solution. And so I think it's interesting to talk about how to choose the right station if you haven't already figured it out. When I go about this kind of conversation, I approach it like a journalist. I look for the 5 W's. I look for the who is using the data, who's buying the data, who's installing and maintaining the station. There are humans everywhere. So the who is actually quite important. The what, as I would say, is the sensor themselves, the information, the data path. That's the what. But the who, the people who are making it happen, are as important as any of the hardware and physical stuff that you can put in the ground. The where, I think, often is the driver of the solution, because you may be in a place that is either very demanding from a geographical point of view, whether it's close enough to ordinary telemetry options, or maybe it's got to fall on satellite. It may be its only option. It may be in a place that is quite cold at times of year, quite hot at times of year, that these extremes will really put a pressure on both the infrastructure and hardware itself, but the telemetry and the power generation that you might need to drive it. So the what matters quite a bit. And then finally, the when. Am I using this for current conditions? Is it a mission critical application? Is the when like all the time, or is the when it's happening that matters most to me? Or maybe I'm doing research and the when is just a very rigorous and reliable data set that I can use over a long period of time. Those matter too. And then finally, the why of the 5 W's is, what decision am I making? What is the most important part of all of those questions, so that I can really fine tune the priorities of things. So I may be very, very interested in the absolute best rainfall measurement I can get, Well, to do that, I might need to heat the rain collector. And to heat the rain and shield the rain collector, maybe I have to find my way to power so I can get all that to happen. So there may be things I have to, maybe extra effort I may have to put to get the answer that I want in a certain case. Or I may have a place that is so remote, I need absolute reliability, longevity, a solar system that will not quit on me. I might be driving it in that just because of how remote it is. And so the other parts of the absolute accuracy or some of the other pieces may fall away because I really need to have that place more than anything else. So when you go through it, I mean, these are just some of the questions to answer, the where and what the choices are. There may be regulatory requirements here that force you up the chain, as it were. Maybe there is a specific standard to follow. Well, the standards can be handled, but usually at a higher cost. So the one thing I haven't mentioned down here in key factors that underlies it all is how much is this going to cost me, right? And so when you walk through, you can go for your ideal, and then you can see if it's fitting within your budget. If not, then we can obviously work on ways of really honing in on the most important pieces and still fitting the need and fitting the budget. Just important to know that there are a lot of questions to be answered to get to the real answer here in terms of the right solution that happens to match the industry and the need. And it really can be a fairly personal question when it gets down to an individual weather station. So these are the kind of questions we love to answer, and we love to figure out the right solution. I think what's nice to know is from AEM's point of view, we have the tools. We have the way to move from the backyard to the airport. So we have the answer. We just have to get it and work together with you to find it. So just quick key takeaways. As you can see, the stations are not the same. You have anywhere from simple setup, durable materials, lower specs, all the way up to a high maintenance WMO certified 10-meter tower, right? So monitoring is truly not one size fits all. You really need to get to the point of using the data. And to use the data, you really need a place that you can interact, you can make your decisions. And if you're in an Elements 360 platform, as an example, you can rely on disparate sources of information all finding their way to a central decision point, which obviously can make your life a lot simpler. You know where you're going when you need to have a question. Finally, the quick sales pitch. We think we're really good at it. We can definitely work with you. We're happy to work with you, whether you already know what you want or you have no idea. So, and with that, I'll turn it back to Liz.
Yeah, thanks, Bjorn. Thanks, Russ. Lots of great information and lots of different options for sure. Like you both said, we've only just touched on a couple of examples. There's a lot of folks that have different use cases or different industries or things like that. So now we are going to have some questions. We had a couple of related questions, probably specific to the Vantage. So when you're thinking about the Vantage, how badly is wind data impacted if the Vantage is mounted closer to ground level rather than at 10 meters? And then a sort of a follow-on was, how is the rain and temperature data impacted if the Vantage is mounted at 10 meters? Trying to basically get to what's the best elevation for installation.
Yeah, this is always a fun question. When someone asks you where to put the weather station or what's my best plan, and what's always true is you're going to get the data from that spot. So if you are in a compromised situation, maybe there's a wind shadow, maybe there's some things, it's always your best effort. But I think the best thing you can do if you're putting it in a place to quantify the sighting of it, and obviously do the best you can in those situations. In the particular case that you're mentioning there, where you've got a 10-meter wind speed that you're desiring, at the same time you have a 2-meter perhaps temperature, wind, rain. The Vantage Pro, which you don't see in those pictures, actually can be separated, and we have cases where the wind sensor is sighted at 10 meters, and then they drop the cable connection down to the 2-meter level so that both can be handled. But again, this is presuming that you actually have a 10-meter tower to use. So a lot of times what's important is what do you have to work with? What's your desire in terms of the data output? Even in the Vantage's case, we can handle it, but there's some infrastructure you have to put together to get that 10-meter tower and to prop it up. But But yeah, to answer the question of information gathered at different heights, the most important thing is that you know and can communicate where you put them, because I think that helps anyone who's analyzing and using the data to understand if there is anything that will be different about that wind. If it's only at 2 meters versus 10, that's good to know, so that you can expect that it's probably a higher value the higher you go.
You mentioned extreme heat. Do you have a wet bulb globe temperature measuring instruments?
Yeah, it depends on the situation where you need this. On the one hand, we have the black globe sensor in our portfolio. Also, every and weather station we presented today, also the Apex line, we can add this parameter if needed. And on the other hand, we have also software solution we can provide. So definitely share the application with us, and then we will find the right solution for you.
Yes, and I'll just add, just for interest for anyone who's not aware, that black globe WBGT, wet bulb globe temperature, it's an emerging standard for human safety. The example I gave of a football field is leaning on this designation to understand whether it's just too hot for kids to be outside, or whether they modify their activity or they have to cease their activity altogether, just from a heat stress point of view. And AEM currently can provide both a black globe sensor, which is a physical sensor that you have to place in a case that's hopefully relevant to the situation, or we also do calculations based on solar radiation and some other information. So we can create a wet bulb globe temperature reading even in a case where you don't have the black globe sensor physically on the field. You can still gain that information with calculations too.
Okay. Do any of the Vantage stations, or I'll expand that to be any of the weather stations, have lightning detection, or is that an add-on?
The Vantage station does not have a lightning sensor. So the question is, where is the data? How do you get the data? Where's it coming from? Well, AEM as a company is a leader in lightning networks, meaning there's a whole network of operated lightning sensors globally, and they're used to find the lightning, whether it's cloud to cloud or cloud to ground lightning anywhere in the world. So at the moment, AEM is fully capable and is actually a leader in providing lightning data, even to the point where you can create a circle around you and get information and alerting if you're in it. Not in the Vantage side of things. It's I would call that more in just the E360, the software side of things. It's data coming through to the central point, and then as an E360 customer, it's the module you can have. But from the specific Davis or Vantage centric stuff, we're not there yet.
All right. So there was a question, do any of the weather stations connect to the Weather Underground website or have the ability to do that?
They do. What's interesting about Davis Instruments, the product line, is it's built up over time to have a few places where data is forwarded regularly. One is the Weather Underground. There's actually a setting you can forward your data, and it on a schedule will update the Weather Underground right through the interface. There are also abilities to upload to what's called the Citizens Weather Observer Network, or the GLOBE program, which is an education-based system. We're contributing to a lot of large networks, and it's something that you can, if you're an owner of a weather station, even the simple Davis Vantage station, you have choices in the software to basically decide where you want to push that data along. And yeah, it's built right in, actually.
Okay, we have kind of a really interesting question, because as we talk about, we do floods, wildfire, and severe weather, and there's definitely blurry lines, especially when it comes to flood risk management and severe weather. So this question kind of blurs some of that a little bit, but can you add sensors for road surface temperature and snow depth?
This is definitely a nice thing about Elements 360, that we can add a different type of stations, but also, to be honest, and on this point, from the AM perspective, we have there a portfolio where we can add a snow depth sensor and get the actual temperature road condition. That is what we can do in combination with road sensing. We have this type of measurement that we can measuring the snow height, the condition of the road in case of temperature, and providing then, depending on the different type of forecasting through Elements 360.
Okay, so does Elements 360 support third-party sensors and standard protocols? And some of the examples here are Modbus, STI-12, NMEA, MQTT.
It's a lot of acronyms of the question.
So it combines a lot of points, and maybe we can split in this question at the end. I can answer this question in this way. So when we take a look to the stations we presented today, that is our package where we see how we would like to acting in the market. And we are using their data logger system at the end that is from perspective today really flexible and bring the data from the station itself to Elements 360. That means there is a point on the one hand on flexibility. If we have there some sensors at the side that supports this types of protocol. We have spoken about SDI, Modbus, and so on. Here we go. We can connect this to the data logger and really flexible, and then check on the integration side to display the data in Elements 360. On the high level point, if the customer have already data and would like to share this with, we have then definitely deep dive in this and go case by case. For this, we have a professional service team, and we can then catch up separately and take a look what are the needs at the end and what are the specific data at the side.
Just to add quickly, I think we do specialize in acronyms. There are cases where we can interact at the hardware level. So you may have a sensor that has a certain protocol, and we can have a conversation about which ones of our logging solutions and telemetry will get that sensor you're looking for all the way, the rest of the way home. But as Bjorn said, you may have cases where the data already resides somewhere. That's just a matter of us stitching together the data source, and we can bring that in also as well into the Elements platform. So you may have a completely separate operating data collection, and then we can act as the last mile to get you to where it's a single interface at the end. So we can work both ways.
One more question. Can I post my weather station information to a web page so the public can view it?
You can. It depends. It's going to depend on the weather station and what the next point is. But in every case, the answer is yes. It will depend on which one we're talking about in terms of how we're going to do it. But yes, in general, and that's something certainly if you have a follow-on question with any of our folks, we can show you how we can move that in. But we are definitely, as a company, very interested in spreading data to the point where we can either inform communities better or help communities sort of interact and give back part of the information. Even from the old days in Davis Instruments, is people wanted their weather first, but they wanted to share it. And so we are as interested as anyone in getting that data out to people so that they can spread the word, and either for the community or for your group or whatever. That's certainly possible in anything that we sell.
Yeah, and I know Elements 360 today we have customers that are exposing some of the data that they have in certain ways to their community, and that's one of the things that they're looking for. So I know there's the ability to do that through Elements 360 as well. So that's all the time that we actually have for today. Thank you so much again for joining us, and a big thank you to Bjorn and Russ for leading today's discussion. We are excited about the role that these weather stations can play in supporting your operations, and we do look forward to continuing the conversation with you. Thank you so much again, and have a great day.